Hello, ladies, gentlemen, and non-binary. Thank you so much for joining us this afternoon, and for some of you, pretty late night, but I'm super happy that you're here. I'm Amelia Thompson, your host of the Wurth Electronic Webinars, and today we are welcoming a brand new presenter. Jared Burke is a magnetics design engineer at Wurth Electronic right here in Watertown, South Dakota. Now, today we are going to be discussing power transformer design in this webinar, transformer design, choosing the right bobbin package for your magnetics. Now, if you have any questions during today's presentation, feel free to ask them in the questions box. We do have that open now. If you want to test it out, like I said, the questions box is available. Feel free to ask questions about your design, anything you have regarding custom transformers, and hopefully we will be able to answer them later on. Now, if your questions don't get answered at the end, maybe we need to go into more detail, maybe you want some custom transformers, we got you covered. Or if you think of a question later on, simply reply back to our follow-up email here for you at we-online.com. That's here, the number 4, YOU, at we-online.com. As a reminder, because you registered for today's event, you will automatically receive the recorded video on demand, as well as a PDF of the presented slides when they become available sometime within the next 24 to 48 hours. Again, look for them in that follow-up email here for you at we-online.com. And as I mentioned before, one lucky attendee from today's webinar is going to win a prize from Wurth Electronic, and I will announce the winner in the follow-up email. So again, the perks of joining us live. Next week, we have 2 special presentations. First, on Tuesday the 21st, we are going to have a special Q&A session on red cube and high current contacts on the PCB. That is at 8 a.m. Central Time. And this webinar is hosted by my German counterpart, Marcus Eberle. And then the next day, join me. We're going to be back in the studio on the 22nd presenting USB 3.1, More Than a Connector, a Solution. Register online at www.we-online.com/webinars. And of course, huge thank you to Digikey Electronics, the exclusive sponsor of all Wurth Electronic webinars. I'm going to hand it over now, and let's begin today's Wurth Electronic webinar with Jared Burke and transformer design, choosing the best bobbin package for your magnetics.
Oh, thanks, Amelia, for the great introduction. Thanks to everyone for bearing with me as I do this for my first time and learn the process, and hopefully I'm doing everything correctly. So anyway, we'll go ahead and get started. So yeah, hello. Welcome to our webinar on choosing the best bobbin package for your magnetics. As we said, my name is Jared Burke. I've been a custom magnetics design engineer here at Wurth Electronics for about 10 years now. So anyway, there's a wide variety of packages available for your magnetics, which can cause some confusion. I'm sure some of you have already gone through that. So while I'll be discussing a few of the most common package types individually, it's not my goal to acquaint you with every style available. Honestly, even after a decade as a magnetics designer, I still come across packages that are new to me. So I guess I'd just like to help you learn some of the terms associated with magnetics packages, as well as some of the reasons why one style might be preferred over another for your particular application. So, hopefully the information given here will help to demystify the choices and give you a good starting point for discussing the best option for your project with your magnetic supplier. So just a quick overview before we get into the details. We're just going to start off with definitions, briefly, package naming conventions, overview a few common package styles, then next kind of get into the reasons why you would choose one package over another one. After that, we'll review extended rail bobbins, orientation, again, more just defining a few terms. And then we're actually got 7 individual package styles that we're going to go through today. And after that, we'll talk briefly about some special purpose packages, and then we'll wrap up and take your questions. So here we go. All right, first off, start by defining a few basic terms. Probably most listeners will be familiar with these terms, but we'll go through them anyway. So the core is the shaped ferrite component that's whose job is to contain the magnetic flux. Here, that would be this over here is the core shape. The bobbin, which is down here, is the molded plastic component that supports the windings and holds the core in place. And then together, these two define what we call the package. And this here shows a completed transformer. So let's see. All right, next we'll talk about the package naming. The naming conventions can be a bit confusing at first, but once you know how to read them, you'll see that there's actually quite a bit of information in the name. The first part of the name, in this case EE, right here, defines the core shape. And we'll talk more about core shapes later on in the presentation. I guess for now, just remember that the core shape is usually defined by anywhere from 1 to 3 letters. Oops. Sorry for my little technical difficulty here. The second part of the name is the core size, although the size naming conventions can be a bit inconsistent from package to package. In this case, the size is listed as 25/13/7, and this gives us the nominal length, width, and height in millimeters of one core half. So, for this one, it's fairly standard, but despite the inconsistencies from package to package, the core size numbers will almost always relate to at least 1 or 2 dimensions of the core itself. So, all right, so these are 7 common package styles. Definitely not a comprehensive list, but these are very common in the industry. I'm sure most of the listeners will probably have seen one or all of these. They're used for catalog parts as well as custom parts. And each of these styles is available in several sizes. And each one of them has attributes that make it attractive for certain applications. So in a bit, we'll go over each of these in more detail. For now, let's just spend a couple minutes discussing why you might choose one package over the other for your application. And we'll kind of discuss that in generic terms starting off. So, all right. So what drives a decision to pick one package over all the others? The most important characteristic, I'd say, is the shape. Do you need a low profile package where space is limited? Or do you have a densely packed PC board and need a transformer with a small footprint? Even within a given core shape, the package form factor can be greatly influenced by bobbin choice, with many being available as either horizontal or vertical orientation. And we'll talk more about that shortly. The second most important factor, and maybe the most important for some applications, but would be cost. Choosing a package that's common in the industry, or choosing one that your particular magnetic supplier uses frequently, are sure ways to reduce cost. So be sure to discuss automation with your magnetic supplier if your application is high volume, as package choice can greatly affect the level of automation available. And I really can't stress that enough. And there's 2 reasons for that. One, your particular magnetic supplier may have invested heavily in tooling for a couple packages that they do commonly. And the second reason is that certain bobbin configurations just lend themselves really well to automation, and others are much trickier to automate. So I'm not going to go into that a lot in detail because it really depends on which packages you're discussing, but just be aware that the choice of the package can substantially affect your end cost or your ability to automate. So here's a few other details why you may choose a particular package. Criteria like low EMI, the need to run it through pick and place, or a safety standard would affect package selection. So, in a bit, we'll go through several common packages one at a time and kind of discuss how they relate in each of these categories. All right, I guess before we start discussing those individual packages, we're going to define a couple more terms. So the first one is extended rail bobbin. Extended rail bobbins are used to increase the creepage and clearance distance in applications where safety standards need to be met, especially on small core sizes. While there are some standard extended rail bobbins available, these often need to be custom designed for each application. Still, using extended rails is a very effective way to address the safety distance challenges. Now shown here are a couple of EFD25 packages, with the only difference being that one has an extended rail and one is I guess more of the catalog standard package. Also shown is a new PQ extended rail package recently tooled by Wurth Electronics. One last set of terms here we'll discuss is orientation. So package orientation is determined by the bobbin design. The horizontal orientation positions the core in a way that minimizes height, and I would say is probably the most common orientation overall. Alternately, the core can be turned 90 degrees for a vertical orientation that minimizes the PCB footprint. Some package styles are only available in one orientation or the other, but many are available in both. Okay, well, I guess as we discuss specific packages, I'll show you a list and some photos like on this slide here. And I've put green stars next to some of the attributes that make the particular package especially useful, and red arrows next to the attributes that the package maybe isn't quite as strong in. And this is real general because a lot of these strengths and weaknesses are going to be dependent on your specific application. So, well, anyway, our first one is the ECore, or EE as also known. And of course, each core half is shaped like a capital letter E, which makes the name a bit obvious. Unfortunately, this easy naming doesn't hold for most of the other packages we will discuss. In fact, as a kind of amusing side note, we sometimes get into discussions within our engineering group about how they came up with certain names, and there's been a lot of speculation. They don't all make a lot of sense, but anyway. So the EE package is probably the most common and versatile package used in the magnetics industry. And I might get people who will disagree with that, but I think in general it's very widely available. It's kind of a go-to. It keeps costs low. The core shape is really simple, and you'll see this as we go through some of the other core shapes later, that you can see the geometry is more complex, which can drive up the cost of the core itself. And so I think because the core geometry on this one is so simple and cost has been kept low, that they've developed a wide number of bobbins as kind of standard. So, and that all that together is combined to make this probably the most common package. So, unfortunately, this requires external shielding for applications where EMI is concerned, and it's not really suitable for pick and place unless you add a separate cap to it. But again, overall, those are probably the only two maybe drawbacks. Overall, I'd say the EE is a great starting point for most applications. All right, up next we have EFD. Now this one is, I'd say, the go-to for many applications that require low profile. The unusual shape can create some challenges during winding, but the EFD is still very common. Many EFD parts use a metal clip to retain the core halves, which doubles as an excellent flat, smooth surface for pick and place. Unlike the EE package, there aren't as many different bobbin styles available, and the EFD package is only available in the horizontal orientation. So there's a few common EFD sizes. I'd say EFD 15, 20, 25, and 30, but there's also been a lot of custom EFD style packages that have been developed for specific industries. So while I say that there isn't a lot of standard bobbins available or a wide variety of bobbins available, it seems to be one that's popular to use as a jumping off point for a lot of custom designs. So definitely one to consider. If you need low profile, this is probably the one you'd start with. All right, so next here we have the EP package. So several sizes of the EPs have been manufactured in very high volumes over the years, making this one of the most cost-effective packages on the market. Now, while EPs are available, they are available in through-hole versions. The surface mount option is by far the most common, and the flat, smooth core top surface is excellent for pick and place. Additionally, this core shape surrounds the winding on 5 sides, inherently providing some EMI shielding. EPs are one of the smaller packages on the market, so they aren't great for high power applications, but are an excellent choice for lower power applications that require low cost. There's just this extensive amount of tooling that's been developed for automating EP packages. So again, if you're looking for a low cost option and your power level isn't real high, this might be your best option. Okay, now I'd say the first 3 that we covered, the EE, the EFD, and the EP are probably the common ones of the group. Now we're starting to get into some that are maybe a little more specialized. First, we'll discuss the ER. Now, the ER package, the small versions of the ER package, like the one shown here, are significantly different from the larger versions. So I'm just going to treat them separately. Even though they have the same name, we're gonna treat them differently and have 2 slides on those. So like the EP, these small ERs have good core surface for pick and place. They're also very low profile, but the small winding area limits their usefulness in some applications. So they're available exclusively in surface mount and are a great choice for low power, low current applications where height is minimal. So again, if you want that low cost, low power surface mount part, you probably start with the EP. If the EP is too high because it's kind of a square shaped package, this would probably be your next best bet, even though the cost on these is going to be a little higher. But they're very, very low profile. So now we see the large version of the ER, and as you can see, they really don't look anything like the smaller ones. So and these are available in both horizontal and vertical. These have a round bobbin barrel, and so they make really efficient use of the winding area. So they work well for high power applications. You can get good efficiency out of this type of package. And they're not as common as some of the other ones, but honestly, in my opinion, this is one of the best packages on the market. And for a lot of my designs, I steer customer toward these because I think they have a lot of positive attributes. All right, so next up is the ETD. And really it's very similar to the larger ER packages. And if you see compare the core shape between the 2, you'll see it's almost identical. So like the ER, these are a real good choice for higher power applications. The larger size of these allows plenty of creepage and clearance distance without the need for extended rail bobbins. So these are kind of a natural go-to for higher power applications where safety distances are required. And honestly, most high power applications do require some safety distance. So basically, these are similar to the ER, but are available in even larger sizes. They kind of start, the ETD sizes start where the ER sizes end. So, okay, so here we have the PQ, which is our second to last one we're going to discuss. These are most commonly used for inductors, you see they do have quite a few pins, but the way the pins are arranged, it's difficult to use the ones on the outside. And since these have such a high core cross-sectional area, you can get pretty good inductance without having a lot of turns. So these make real natural packages for inductors. We can adapt them to transformer applications, especially if you don't need a lot of windings. But now this core shape probably provides a little bit of EMI shielding as compared to like the EE packages. And they are available in quite a number of different sizes. So, and again, we've recently started using some of the PQs in extended rail versions. There's been some new bobbins that have hit the market, allowing these to be used in some of the higher power transformer applications that require safety distance. So, and again, now you start to look at this core shape as compared to the ECore, and you can see how now we're getting more and more complex with the core geometry. And again, that's one of the reasons why this type of package, even though it works really well from a magnetic standpoint, has a little higher cost, which will limit its usefulness in some applications. All right, so the last one is the RM. This is an interesting one. The RM is really kind of an old favorite. It's a good choice where high power density is needed. The square footprint allows for ease of PCB layout, especially if you're using an array of these, putting 8 or 10 of them on one PC board. So because of that square layout, though, you can see there how the pins are clustered very close together, and that makes it difficult to use heavy wire on these packages. So if you have an application where your current is high, the RM becomes a more difficult choice there, even though you have some of the attractiveness with the power density and the layout. It's the high current on an RM is not a real good option. And also, since those pins are clustered so close to the core, it makes it difficult to meet safety distances on this package. It's probably a good package for an inductor. We do see a lot of customers looking at this for transformers. So there are a couple bobbin versions available on the market, and I apologize I didn't show those here, but they have developed a couple of bobbin versions that move those pins further out. So that makes it a little more useful for higher current or higher safety applications, but the trade-off is you're losing one of the advantages of the RM package now because you don't have this nice square footprint. So yeah, I guess if a lot of people like the RM because they're used to it, it's been around for a while, but I guess if you're looking at using it for your application, definitely discuss it with your magnetic supplier before finalizing that, and they can hopefully help you with whether or not that's a good option. So all right, I'm almost through my slides here. I got one last thing I'd like to discuss, some of these special purpose packages. So the preceding 7 common packages cover the vast majority of applications, but there's many special purpose packages available, and I just have a few shown here. So these special purpose packages can be used to cover applications with unusual space constraints or extreme safety distance requirements, or other, industry specific needs. And some of these that have been developed for one industry have been adapted for other industries. So, there's some interesting applications out here for these. If all else fails, it is possible to custom design a package specific to your application, although this usually does require an investment in tooling and take some extra development time. So, but we have had customers where we've developed a whole new core and bobbin for them. So yeah, I guess that's all I have for content right now. I guess, in conclusion, proper package selection can help you optimize cost, space, and features for your application. I know I've said this a few times already, but it's important to involve your magnetic supplier during the design phase so they can help you make the best choice. Anyway, I hope this package selection guide has helped, and I'd be happy to answer any questions at this point. So thank you.
Excellent job, Jared. Thank you so much for presenting today. We do have some questions rolling on in. I'm going to give people a few minutes to type them in. We're going to start with the first one here. For offline flyback, for example, our WUOST, which is a standard offline flyback transformer, how do I know the size of Y1 cap between primary and secondary sides? Some chip manufacturers in their development kits just put the largest legal size, 2.2 nanofarads, but I don't like that touch current, so they want to lower it as much as possible. Do you have an answer?
That is probably a little outside my area of expertise. I guess what I can say for offline flyback, we typically will use an extended rail EE package. When it gets into sizing the capacitors and whatnot, yeah, that's probably something that's going to have to be discussed with the IC manufacturer. So I'll have to apologize and not really directly answer that, but yeah, we typically will use the EE extended rails as a starting point for a lot of those. So.
And just to follow up with that, if a question doesn't get answered here, if we need to go into more detail, we will gladly answer this after the webinar as well. Our next question, Jared, you discussed higher power or heavier wire. What do you mean by these? Is higher power 100 watt, 1,000 watt, or 10 kilowatt? And is heavier wire 20 or 12 gauge?
Well, that's a great question. It's all relative. So what's high power for an EP might be low power for an ER. There are charts available kind of showing for a given size, like say an EP13 versus an EP10, what you can expect for a reasonable power requirement. So yeah, it's all relative. I guess when I say higher power, you pretty much need a larger package. So for something like an EP, they're only available up to commonly an EP13, whereas like your ERs are available ER28, which is probably 4 times the size. Current, that's a good question about current and wire size. So when it was a little hard to tell on the scale of the pictures that I did, because of course they all look the same size, but if you see the packages next to each other, what you'll see is an EP package may have 2 millimeters between the pins and an ER package may have 5 millimeters between the pins. So if you're having to use applications that are 10, 15, 20 amps or more, and you're needing to put on 20 gauge wire or the equivalent size lits, in some cases it's not even physically going to fit on the smaller packages. So high current is kind of a special case. You really need to, again, talk to your magnetic supplier. You need to find a package that has a lot of spacing between the pins. You need a package that has robust pins so that when you're wrapping, a 20 gauge wire around a tiny pin, that you're not going to damage that during the winding process. So yeah, it is relative, but yeah, hopefully that kind of helps touch on it a little bit.
Absolutely, and you actually helped answer a couple other questions that have come through. Our next question here. Can you please discuss considerations for the LLC Resonance, including leakage inductance?
Yeah, sure. That's a good question as well. So oftentimes with the LLC designs, the customer will want to have the resonant inductor integrated into the transformer. So the leakage inductance that's inherent in the transformer can be used as in place of a separate resonant inductor, which is great. Anyone who's designed LLCs knows that that's one way they can take a major component off their PC board, saving cost, whatnot. So, what is typically happens there is you're trying to increase the leakage inductance over what you would get normally. And that's really one of the most unusual things about LLC as compared to all the other topologies with flyback and everything else, forward designs, leakage inductance is a parasitic. It causes losses. Transformer designers try to minimize the leakage inductance as much as possible. Customers then try to ask the transformer designers to minimize it further. So with LLC, you actually typically need to increase leakage inductance. This is done by adding space between the windings. So for example, instead of having your primary and secondary windings wound concentric on one side of the bobbin, you'll actually split the bobbin into two sections and wind the primary on one side and the secondary on the other. So having a bobbin that has two winding sections is typically something that you look for in an LLC. Now, the interesting thing about that is that that does limit your bobbin selection quite a bit and your package selection, because there's just certain packages that aren't made that way. I talked about the ER, the ETD. Those two have a lot of two-section bobbins available. So ER and ETD are two packages that are used really commonly for LLC because of that. So hopefully that answers the question.
I think it does. A few more questions coming in, and then we can wrap everything up. Our next question here, which does Wurth prefer for higher creepage requirements, margin tape or triple insulated wire?
Now that's an interesting topic. Okay, so margin tape is typically thought of as the lower cost option, but in some cases, triple insulated wire can be a more robust solution. A lot of it will depend on how many winding turns that you need on your secondary side winding. Triple insulated wire is usually sold by the foot. So if you have a transformer that's requiring 5 turns, it might be better just to use triple insulated wire. If you have a transformer that's going to require, 50 turns on your secondary side, that can get pretty expensive. And in those cases, margin tape will often be a more cost-effective option. The other consideration is margin tape only gives you creepage distance where the margin tape is put. Sometimes within a transformer where there's high safety distance requirements, there is almost, I don't really want to say hidden areas, but areas that are difficult, not intuitive, to where you might have a creepage distance issue. In those cases, triple insulated wire will solve that issue. It's because you're guaranteed that wire is insulated for safety all the way through its entire winding. So the only place in those cases you need to worry about with triple insulated wire is right at the connection to the pin. And that's why sometimes we'll use extended rail bobbins, because that will take that pin connection that's uninsulated after soldering and it'll move it away from the core. The core is oftentimes usually considered to be part of conductive, so not allowed to be included in the creepage and clearance path. So yeah, I don't think I really answered the question. I personally use both. I probably use triple insulated wire more than I use margin tape, but it's probably a 60-40 split. So it really depends on the application, the cost objectives, the package chosen. So. Yep.
And when designing a transformer, there are just so many factors to consider. So it all depends. Like our next question here, what package do you consider has the best magnetic field containment? And this is in consideration of avoiding EMI cross-coupled energy issues.
We have pretty good luck with the EP package, because as you could see there, that contains wraps around the winding on 5 of the 6 sides. So RMs are also okay, but I would say probably just in terms of the core itself of the commonly available packages, EP is definitely the better choice for if you're concerned about EMI. But of course, anyone who's designed for EMI issues knows that can be a little tricky, and sometimes it requires some experimenting. We have several other weapons in our arsenal, I guess you'd say. Sorry for the violent metaphor, but It is sometimes a battle with EMI, as anyone who's fought it knows, but we do have several other tools, maybe I'd say, that can be used to help that. So.
Now, we do have our final question here. A few of these questions are really going into detail, so we will gladly answer them after the webinar. I'll make sure that all of the technical questions get sent right over to Jared and his team, and they are the experts in their field. As a reminder, because everybody registered for today's event, you will automatically receive the video on demand as well as the presented slides within the next 24 to 48 hours. Simply look for that follow-up email. All right, our final question. This person has seen the capabilities catalog, our faithful capabilities catalog. Is this something that they could use to actually choose their package style?
Yeah, so our custom capability catalog, as we call it, is got, I don't know, there's probably at least 100 pages in there. That has pages for not just for each package style, but for each size. So for example, EP11, or I'm sorry, EP10, EP13, different bobbin configurations are all kind of handled separately. It does also have some of the charts I mentioned earlier relating the ability of that package to handle certain power levels. So if you're wondering, say for example, you have this 50 watt and you want to know 50 watt flyback operating at 100 kilohertz, and you want to know if the EE25 is big enough, or if you need to go to an ER28, you can look that up in there and compare the power abilities of those packages to support those power levels. So, yep, it's definitely a good tool.
We use it a lot. All right, thank you very much, Jared, for presenting today. We appreciate it.
Yeah, thank you. I appreciate everyone's time. I hope it's was useful. So thanks a lot, everyone.
Absolutely. And thank you everyone for joining us for today's Wurth Electronic webinar. Don't forget, next week we have two very special presentations. First, on Tuesday, the 21st, it's a Q&A on Red Cube and high current contacts on PCB. And the webinar is hosted by my German counterpart, Marcus Everly, at 9 a.m. Central. And then the next day, we are back in the studio on Wednesday, the 22nd, presenting USB 3.1, more than a connector, a solution. So register online at www.we-online.com/webinars. And don't forget to listen to our new Wurth Electronic podcast. It's the What's Up Radio podcast, where I bring application notes, blogs, press releases, and even our faithful webinars to a strictly audio format. You can find us everywhere: Spotify, iTunes, Google Podcasts. We are all over the place. That's the Wurth Electronic What's Up podcast, with our newest episode being EMC filter for DC to DC switching controller optimized. Again, it's the Wurth Electronic What's Up podcast. I'm Amelia Thompson, and until next time, have a great day.